Okay, natural resources. We have looked at erosion, and we have looked at one major part of erosion, and that is soils. Now we're going to move into another major part of erosion, and that's water. And so, with this particular part, we're not just going to talk about the way that water works as far as erosion goes, but the way that water works in general. It's a huge part of our natural resources course. And the reason is because, most of our entire earth is water. We have much more water on our earth's surface than what we have land, about 70%. When you're looking at the actual amount of water on earth, 330 million cubic miles. Most of this water is salt water, though. And so whenever we are looking at water and its uses, really, we're hopefully mostly looking at fresh water. And so only about 2% of the water that is on our planet is actually fresh water. And so we are looking at comparatively a very small amount of water that we actually use for our own purposes, because we obviously can't drink ocean water. So only about 1% is in glaciers and ice caps, and so that 2% is what we're talking about whenever we're talking about water conservation. Um, this is just a picture of the hydrologic cycle, another word for the water cycle. And you have probably talked about the water cycle ever since you were young in science classes. But there's so many ways that water actually can move. I mean, you're looking at condensation from rain. You're looking at condensation from snow. You're looking at condensation from um, hail and different types of precipitation. But then you have water that is evaporating from lots of different places as well. You can see in this picture, you've got ice and snow and glaciers, and then you've got volcanic steam, and then you've got the evaporation just from natural everyday evaporation. So when we're looking at the water cycle, this is powered by solar energy, if you think about it, because you have to have that solar energy and the heat in order for the water to be able to evaporate. And so when that heat and the solar energy causes it to evaporate, it's going to be taken up into the atmosphere and eventually becomes so heavy and weighted down that it's going to fall as some sort of precipitation. So this hydrologic cycle is where water from the surface of the ocean and other types of water are going to be moved into the atmosphere through the process of evaporation, and will eventually come back down to the Earth's surface. Once it's in the atmosphere, it's going to condense, it's going to form clouds, and then those clouds are going to cause it to be released. It becomes so heavy that it has to go somewhere. It may be rain, it may be sleet, it may be hail, it may be snow. My personal favorite is snow, but we don't get it very often. But whenever we're looking at different types of precipitation, most of the time what we're thinking about, especially in our area, is going to be rain. So if it's any type of precipitation that is in liquid or frozen form, is called meteoric water. So basically, when we're looking at precipitation, we're looking at meteoric water. Um, Surface water itself is going to be found in lakes and ponds and streams and rivers. It's used repeatedly. It makes its way back toward the ocean, and water is constantly moving. And whenever I mentioned on this page, well, actually, I think I discussed it in the announcement, that you have a short video on this page that asks you, do you drink dinosaur pee? And most of us don't think about the idea of going and getting a big old glass of dinosaur pee, but we really are recycling all the water that is on Earth. We're not making new water every day. Water is cycled and filtered and recycled, and it's filtered through the hydrologic cycle, through the condensation and the evaporation. This acts as natural filters. So we're not making new water. All the water that is here is the same water that has been here and the water that will be here. So we use it, but then it also gets recycled and reused. Runoff water does not soak into the ground or fall directly into or onto surface water. Runoff water is water that has come from somewhere. It has rolled down a hill. It has run off the side of a roof or something like that. Groundwater soaks into the soil, and so those are the difference between the two. And we're going to look more at groundwater and where some of that water actually comes from. So when we're looking at sources of water, um, surface water itself is going to be water that is in a stationary place. Ponds, streams, rivers, reservoirs, lakes, oceans. This is water that is found on the earth's surface and remains on the earth's surface. We are not talking about little puddles that come and go. We are talking about something that is a source of water and remains a source of water. There are some areas that the water doesn't necessarily infiltrate the soil and it runs downhill into a location. That's called a watershed. And you can see with this picture right here what we're actually talking about as far as a watershed. You've got water that's coming down streams, down these hills. It's getting rained on. As it rains and snows, it's adding to the water, and that water all has to go somewhere. And the watershed is going to be that area that the water goes to. So you can see right here the actual watershed itself, and you can see how it's all coming down that hill. Groundwater is water that comes from within the earth. I always used to think it was interesting whenever I would watch movies and you would see these people that are walking through with these sticks and they were using divining rods to try to figure out where groundwater actually was. And that is actually a thing. I know it's weird, but it is a thing. And so they're looking for water that's underneath the ground. And so once you drill it and put a well in, then you can actually use that groundwater from these aquifers that are underground, and that can be the water that you use for your home. So groundwater is water that's found within the earth. It's found in aquifers, and we're going to look at a slide in just a second that's going to show where the largest aquifer is in the United States. But you have to be very careful. You do have to manage it. You do have to conserve it. Most of the freshwater supply that we have, that we use, actually does come from groundwater. So whenever you look at the Earth's surface and you see that 70% of the Earth's surface is covered with water, most of that water that you're seeing is not actually water that we are using or consuming. The water that we are using or consuming, you can't even see because it's actually underground. So it gets pumped to the surface, typically by some sort of a well pump. And the Ogala Aquifer is going to be where a third of all the groundwater is used. It comes from in the United States. And you can see that one particular aquifer right here is a huge aquifer out in the Midwest part of the United States. But there are different types of aquifers all around the country. So this is going to be where we're going to get the water from. You're never going to see this because you have to dig to get to it. So this is not some giant lake that you're going to see in the middle of the country, but it is underneath the surface. So as far as water users and the people that use water, we're going to take a look at several different sources of industries that use water. As far as agriculture, the main use of water is going to be irrigation. Whether you're using it for surface irrigation, and you can see right here, this is what we're talking about with surface irrigation. They're actually using ditches and they're transporting water from a stream to the crops. And so basically they are resourcing the water from a stream or creek or river, and they're using that for irrigation purposes, and just basically taking that water from that particular source. Sprinkler irrigation is going to be where you actually have to have some extra equipment that's put in. You can do it with portable equipment or stationary equipment, and you've got pipes and nozzles and hoses that are actually going to get your water out to where you need it to be. You still could be using a natural source. It's just not going to be like the surface irrigation where you're actually using it from a ditch. Drip irrigation is probably going to be the one that is the most I guess, environmentally friendly because you're not using as much water with drip irrigation and you can put it exactly where you need it. Whereas with some of these others, like with a sprinkler, you may be getting things wetter in some areas than others. You have to calibrate it. With drip irrigation, you can literally lay the pipe exactly where you want it. And it's a tube that has holes in it. And as you run the water through the pipe, then those holes are going to drip soil into that particular area, and you can put it exactly underneath the plants. So it's kind of an exact science as compared to some of the other ones. Industry uses water in a lot of different ways. It just depends on what industry that you're looking at. Water's used more than any other raw material, and the reason is because a lot of these processes you look at having to be washed, and a lot of it is not necessarily used to be consumed, but it's going to be used in a washing process or cleaning process or canning process, and then it's going to be cleaned and reused. So most of what you're doing as far as industry is concerned, most of that water is going to be cleaned and recycled and used again. Um, it says here that it's estimated that 40 billion gallons of water are used by industry each day, but only 2.5 billion are actually consumed. So you're looking at recycling the majority of the water that's actually going to be used by industry. Um, one actual industry that uses water is going to be hydroelectric plants, and you can see this dam that's built here. Water is going to be used to make electricity, and so in this particular type of situation, you've got a nice big water feature here, a lake or whatever, and you're using that water to actually turn a turbine that's going to make the electricity that we need. So these are hydroelectric plants. Um, the United States actually leads the world in hydroelectric power. We are leaning away from things like coal-fired plants and going more towards things like hydroelectric and solar power, even nuclear power. As scary as is what you think about it, is sometimes thinking about nuclear power is safer for the atmosphere than coal. So we are leaning towards things that are more sustainable, especially things like water and solar and even wind. Finally, domestic uses. This is what we're using water for every day. So whenever we're talking about domestic uses of water, what are you drinking? What are you using to wash your dishes? What are you using to wash your clothes? What are you using to take a shower and brush your teeth and flush the toilet? So when we look at domestic uses of water, we are looking at what you're actually using in your homes. And it says that each person uses approximately 173 gallons of water per day. So thank goodness this is a renewable resource, and thank goodness this is something that we recycle and we reuse. It's kind of gross to think about the fact that all water that you drink has been drunk before, but there are natural filtration processes and things like that. So we do want to make sure that we are being as mindful as possible whenever we are using resources, but it's nice to know that it works the way that it's supposed to, and that we can actually filter out and reuse water. If we figure out a way that we can desalinate water in a way that is economical and doesn't taste funny, I mean, because you can go to the beach and the water kind of tastes funny, then that would be fantastic, because we actually have a much more prolific amount of water to be able to use. But maybe one day, maybe one of you will come up with that invention where we can cheaply and effectively desalinate water. Next time, we're going to talk about water quality and pollution and how we can actually look at water quality and pollution and some things that are clues in the atmosphere or clues in the water that will tell us whether or not we have a healthy ecosystem.